Hello, I thought I'd do a video just kind of sharing some of the things I've been learning a little bit about this interesting open source product called Facebook Profit. And basically, Facebook Profit, it's another aspect of deep learning, machine learning, but it's basically an open source forecasting procedure, basically. It's implemented in R and Python. And long story short, it allows you to forecast and predict the future based on certain trends inside of your data set. And rather than just kind of go into detail about that, I just want to make a disclaimer. I'm still learning some of this stuff, so I am not going to be one that pretends to be an expert in any of this. I just a lifelong learner. And what kind of gave me the inspiration to that, and I want to give full credit to where credit is due, because I'm not going to be one that, you know, uh, learns all this stuff from some course or whatever and doesn't give the credit to them and wants to make you think that I'm some kind of super genius that did this all on my own and came up with this. So I humbly tell you that's not the case. I learned this stuff from a course, and the course that I'm referring to, where credit's due, is this given one here. And basically, it's an interesting course, and it's so far it's been pretty valuable. I've taken several of the modules, and what it is they give you several different projects. They give you 8 to be in total here, and a couple of them they spend a little bit of time using Profit, as well as convoluted neural networks with image recognition and artificial neural networks. So they give you some interesting labs, but they spend a couple of those using Profit. So I went ahead and took both of those, and what you're left, or what you end up with, is a data set that contains like Chicago crime rates, and another one that contains avocado sales data across the United States by regions, by certain states, things of that nature. And you have the ability to predict what the prices are going to be certain times of the year, as well as which regions perform and what months, periods during that time perform better than the others. So if you're interested and you want to take your deep learning and or machine learning, shall we say, levels to another level, and actually do a bunch of hands-on labs where the gentleman gives you assignments actually and challenges, which I really like about it, so you can continue to learn things on. I highly recommend that course. So forecasting, again, is another aspect of machine learning where you're able to, unlike some of the other aspects of machine learning where you run your models, or where you actually train your models and then you can run predictions against those models real time. Forecasting is slightly different in that it projects into the future. So you can actually project based on training your model. You can actually project what the future is going to look like based on your certain parameters that you want to track, for whether it's 1 month out, 5 months out, 12 months out, 2 years out, or so on and so on. So it is slightly different than some of the aspects where you're actually making a prediction real time. So in a nutshell, that's kind of what forecasting is. And like this particular site here says, the advantages is it allows you to capacity plan, set your goals, and detect anomalies, which basically are certain seasons or certain periods that tend to fluctuate a little bit more than some of the others. So without further ado, in order to not really give away too much of this gentleman's course, by the way, this course is created by Super Data Science, and they happen to be the ones that created that other deep learning, machine learning course that I keep recommending in some of my previous videos. And those gentlemen were very nice and kind to allow me to show you some of their labs, just as long as I didn't give away complete content to all of their labs. So I'm going to pretty much do something similar here, and I'll show you Profit and how I used it in one of the labs here, but I'm not going to show you the other lab, just as motivation for you to purchase the course if you want to continue to go and get the examples and things of that nature. But after this little demo, you should at least get a little bit of an idea. And that's the key, is not to actually train you, but more or less kind of like a jump start of about what profit is. So I do want to mention that this lab, is going to have you walk through Jupyter, where the other one had us walk through Spider. So I'm going to start up Jupyter Notebook, standalone, and it assumes that you've installed Anaconda, and you start up your Anaconda prompt. So when I go ahead and do that, it's going to kick this off, and it's actually going to launch my default browser here in Jupyter, which is going to be Opera. And let me go ahead and slide this window over here. As you can see, this is the one that it's actually slid over, and I've got some of the labs that I've actually completed. So I'm going to show you the avocado prices lab. And again, I give full credit to the course, to the author of this course. And what I went ahead and did was followed his examples and followed his workshop. And I changed my parameters slightly in certain scenarios just so that I wasn't just typing in everything that he said. And like I said, throughout the procedure, he actually kind of walks you through certain steps to kind of explain some of the things that you're doing. So I am going to find my lab for this given avocado case right here, and I found it. So let me close this. And I've actually run it. So what I can do is, if you look right here, I've got Jupyter Notebook open, and it's actually going to follow a whole bunch of steps here. You can see there's some cool looking graphs and, just to kind of appease you. But the idea here is we're going to be given a data set. It's a CSV file. And what you can do is really kind of cool here. So I'm actually going to execute some of these steps as we go along here. So if I delete that particular one here, so what we've got here is Jupyter is pretty slick. It's a fully blown interactive, and I think I explained this also in my SageMaker video, because Amazon AWS has Jupyter, but it's a fully interactive environment that lets you kind of save your steps. It saves your documentation. Think of this kind of as like a Microsoft Word document that actually allows you to execute code and or macros real time. So you can actually do data science, machine learning using Jupyter. You can actually type in code snippets and fragments and execute them as you go along. So right here in the first step, where we're importing a bunch of your files, if you hit basically Shift Enter, I've actually executing that. If you see the star right there, that indicates that it's executing. And what I'm going to do is wait for that to finish. And don't worry about this here. This is just missing some of the interactive plot stuff, which I'm not going to demo in this case right here. And what we're doing is we're importing that. But in this given lab, if I go to Project 4 inside of my documents, so this is also in Jupyter. As you can see, it's a web-based system. So when you start up Jupyter, these are your URLs, so you can actually take this URL and open it up in another browser to get this particular view here. But if you look right here, we've got an avocado CSV, and if I click on it, you can see the actual data set. So it's basically a spreadsheet that has basically like from the year 2015 all the way through 2018. It's got data that's across the United States, and it's a data set for the most part. I believe it's probably even sample, potentially even random. But the idea is for certain regions across the United States, like you see here, we've got Albany, and then we've got like Boise and all that. These are some of the parameters. It's like the year, your bag types, whether, they're conventional bags. I'm pretty sure, I'm thinking conventional might be, no, organic right here, some of the other ones right there. Whether they're small bags, total number of bags, the prices. So you'll see where we're going with that. That's our data set. And what we can do is actually read it. So I'm on this line 2, so I actually want to read that in. It's executed it. And what you can do right here is, I've already executed this, so that's why you're seeing some of this data here. But after we've loaded in our data frames using Panda, which is a library for data frames and reading spreadsheets, you can actually interactively type things like avocado, data frame, and if you just hit Shift Enter, what you've got here is what the spreadsheet looks like, but only in a much more readable format. And then you can do things like sort if you want. So I can say I want to actually sort by, let's see, average price. So you use the name of the column in the spreadsheet, and you can just say, you can say sample, my sample, for example, my sample equals avocado df sort, and then I can dump out my sample right there. And I am getting an error here, so I think what I need to do here is give it an array. See, again, I'm still learning right here. So which would be like an array of the column names. Bear with me 1 second right here. I had to go ahead and look up the documentation. It's actually sort values. And you do this right here. So, whoops, if I can only type. There we go. So we're sorting by the average price, as you can see now. And then I'm dumping out my sample right here. So we're going to have the lowest prices right there. You can do some other pretty interesting things. And if you look at this example right here, you can do something like you can add multiple columns in there if you wanted to sort by year and average price. You can also say ascending false if you want to do it by ascending or descending order, for example, by the average price here. So what have we got going on here? We've got ascending sort values by, let's see what we've got going on here. Oops, I had sort values desk. That's not what I meant to type in. There we go. So here I'm doing sort values, ascending order false. So you're going to see the data set in the opposite direction where we've got the highest average price showing up. And, just to prove, if I say true, now we've got the lowest average price. And you can have multiple columns in your sort by just saying by call, comma. So if I actually wanted to do it by year, I could just say by equals, and then I could say year. I think you can do it this way. Let's see what we've got here. By equals call. Oh, you need to specify an array. See, I told you I'm learning this stuff, so I'm kind of glad I'm making these errors, just so that you can see I'm not some kind of a self-proclaimed genius at this stuff. I'm just kind of going fishing here. By equals call, by equals your, comma, average price. So what, you have to do it this way. Stupid me. There we don't go. So let's see here. Sort by multiple columns. So this should work. So we got sort values equals, and then we've got by equals, and then we've got year and average price. Let's take this out too. All right, so what have we got going here? What is this actually telling us? Year is not a valid column. Well, you know what? It would help if I had this case correct. Stupid me there. So I'm glad you're seeing these errors here. So here we're sorting by 2 columns. We're sorting by year and then the average price right there. So that's actually a good sign here. But enough of that. I just kind of wanted to show you some of the things that you can do inside of Jupyter, and you can see the interactive nature of this, and that's what's important. You can also head your data frame, so if you just want to see the first, by default, 5, or if you want to see the first 10, you can type in 10 right there and get this. As you can see, I'm doing a sort by date, and I'm printing out that right here. So you can also do tail if you want to see the last 10 rows. as you can see right there. Some interesting kinds of things that you can do. Also, now that we've loaded our data set, what we want to do here is, we can go ahead and use plot, PLT, which is the plot lib right there, matplot, and that's used for your data visualization. So I kind of did this kind of as a before and after. We're plotting our whole data set. This is kind of scrunchy. So if we actually want to give you more size right here, you can use the figure and the date size right there. As you can see, it's executing. There we go. It finishes right here. So as you can see, your data set is a little bit wider, and this will be a little bit more clear as we go on. Now you can also use another package called Seaborn, which is kind of slick as well. And we're just basically taking the same data and we're count plotting it by region. So what this basically is saying, as you can see, this data set is pretty well balanced all the way across, and it really does contain approximately 350 rows by region. As you can see in this given one right here, which happens to be, I think it's Boise. There's slightly less, but as you can see on your vertical axis, we have our count, and then on our horizontal axis, we have our actual regions, which are going to be in our data set as well. Another pretty cool thing that you can do right here is you can do counts by. So 1 second here. So what we can do right here is if I type in like A right here, it inserts a line. So I can say avocado data frame. And if I just type in region and then I say value counts, for those of you familiar with SQL, this is the same thing as doing a group by. So you're basically going through our data set and we're tracking out, pulling out the region, kind of doing a group by. It's kind of like a sum group by, or a count group by, I should say, more accurately, aggregate function. So as you can see, our data set is pretty well balanced. In the case of New Mexico, actually that was New Mexico, not Boise. That actually had the slightly less column, shall we say. It's this one right there. I was saying Boise, but that's the one that's got this little thing right here. So there's different ways you can use Seaborn and Plotlib to do some plots. So these are just different ways of visualizing the same data. And as you can see, you can also do a count plot by year. So I'm going through the data set, and this just basically says through our whole data set, these are the 4 years with it, and these are the counts of bags, things of that nature. So we could also do region. So if I paste this, you can see how this tool, this Jupyter notebook, is pretty cool for data scientists to use because it is interactive. So here I just want to do one for region, for example. And as you can see, with our given regions, it's pretty much the same thing that we had here. Let's see if I can do total volume. Don't really want to do that. You have to kind of be careful with what you're going to be breaking your data out. We could do type. That makes a little bit more sense because maybe we want to get a count of how many organics we had, units of the avocados. And as you can see, I just did a type right here. So in total in the data set, we've got pretty much well balanced between conventional and organic. So again, that's one of the things that you can do. Here's something else pretty cool. Inside of your data set at any given time, you can save and do a checkpoint right there. So you can actually go and prototype, or this could actually be the tool that a data scientist learns to train the model. Not only can you train the model, but you can also save the model when you're done training it and then deploy it. If you're using SageMaker, you can deploy it to an Amazon AWS endpoint or an Azure. I mean, the options are pretty much endless right there. So here's what we've got going on right here. So the other nice thing that you can do is you can actually trim. You can actually take this original data set right here, this avocado DF right here that has all of these columns, and you can extract out, if you will, into another data set of frames, if the columns that you want. So this is kind of like a cut or a pipe, or where you're just saying, I want to create a brand new data frame called this off of this, and this one's only going to have these two columns here. Why would you want to do that? For speed. If you're going to go ahead and be feeding this given set of data into your model or into Profit, like we're going to do in this case, it's just basically going to make things run faster. So another thing, in order to use Profit, what we need to do is we need to rename some of the columns, or we need to rename our columns that we have in this data frame, particularly the date column. Profit wants it to be called DS, that's your X, and then your Y, we're taking the average price column and we're renaming it to Y. So we're taking these two and renaming it to DS and Y. As you can see, that's what we've done here with the rename. And then if I print that out again, you can see what we've got going on here. We've got columns of data frame DF and Y. So what I am going to do, the reason why this is working here, or the reason why this is not defined up here, is because I haven't really been running this. This is from a previous run, so I am going to run that. Let me go back down here. Okay. Going back up here. So this kind of helped me lose my place a little bit. I was right there. And now if I dump this out, you can see our columns here. So I've redefined that. Now this rename here, avocado profit DF is not defined. Here's what I'm going to do, because I admit I was being a little bit lazy here. When I showed you this is from a previous run. I'm going to rerun this whole set of steps that we have right here from the very beginning. So this is where you can actually stop the kernel and restart and rerun it all. So I'm going to say yes. And it's going to take a little bit of time. As you can see, it's executing all of these steps. In a way, I'm kind of glad that this is doing this so that you can actually get a feel for what's going on with this Jupyter thing. As it starts executing, you're going to start seeing output. And as you can see, it's on this step. It's generated this here. And it's currently on here because we have the star going on. And it's going to, where you see some of these graphs here, these are leftover remnants from the previous run. So don't let that confuse you. What you want to look for is where it's no longer the star, so that's where it's actually executing. So we're actually on this figure right here. I'm going to pause this video and wait for this to finish and complete all the several steps here. So we are continuing onwards right here. As you can see, it's we've got our count plot. We've got our avocado thing right here. This is where I've actually printed out the types from what you saw in a previous step. So here we're extracting out, again, the date and the average price and dumping that out. Now we get to this particular step where we actually want to train the model. I didn't mean to say train the data. I meant to say train the model right here and make the predictions. So we're renaming this. This is where it gets really interesting. So literally we went all of these steps like halfway through this whole document, if you will, before we actually started using Facebook Profit. Now this Facebook Profit on step 18, that was imported right up here. So we're going to go back to, shall we say, step 18. This is where we actually train the model. So in some of the previous videos I did based on, like when you're using the decision tree library or, the SVR, the SVM libraries, those kinds of things, you all basically have to fit your model. So Profit is no different. It's just your model object, and you fit it with the data frames that you've training. So we've actually training the model. This particular thing is done. Now what's kind of interesting is Profit uses all kinds of complicated mathematics, and I do not claim to know all of the science and things behind Profit and the mathematics behind it. But as you can see, and when I took the course, the author made it quite clear that, this was created by a bunch of Facebook data scientists. As a matter of fact, it's by Facebook's data science team. But you can actually read their paper on on some of the logic and stuff that they've incorporated inside of Profit. So you can see the profit forecasting model. I am not going to go through all of this, but you can see how they visualize all of the different samples and try to determine the best approach and algorithms to use. So if you're curious behind the scenes of the algorithms and such that Facebook Profit is using, you can actually go ahead and read the paper on it. But for the purposes of myself, like a programmer who is still learning a lot about machine learning and doesn't need to know the internals of the algorithms, and I would assume a lot of people out there don't need to know that as well because these are tried and true, you can just go ahead and use these methods right here, like make future data frame. What this basically is saying is, based on what we trained our model with, we want it to use the past data, and we want to go forward for 1 year, where each of the periods is like a week's worth of data. So that's our future. And then we actually want to forecast. So it's some interesting things that you can do. So we can actually create a future object that, we can go 2 years out if we were to do something like 720. So it's up to you. And so we create a future object right there, and we can call predict on this with the future to get our forecast. Now, if we dump out the forecast, what's kind of interesting is the forecast is going to show you the existing data that we have, the historical data, because that's what 2015 is. And if you recall, this data set went from 2015 to 2018, but watch what happens when we get to the bottom here. 2018 is as far as the data set goes. Now you look at these lines, like 18,000 line down into our data set. Now we've got 2019 data. That doesn't even exist. That's quote unquote future. Granted, it is 2019 right now realistically, but at the time that this data set came out, it only went through part of 2018. So that's why you're seeing this forecast right here, because it's actually including also a year's worth of predictions. What else is kind of nice is now we can forecast. So we can actually take that model object, and on the profit object, they give you the ability to plot by date and price out a little bit into the future. And what I find kind of fascinating by that, if you look at this, there's like a cut. If you look right here, there's a cut. Everything to the left, which is dark and plotted, this is true, the true historical data from our data set, from what we've trained and all that, true historical. And what you see right here with the light blue, this is our forecasted. This doesn't exist. This is just a projection of what should exist by using a lot of these complicated algorithms that you can read about in that paper, if you decide to read that paper that they have, like this forecasting at a scale. So that's kind of what they're using on these algorithms. So as you can see, they're sort of projecting a slight downward trend. So it goes slightly upwards in this year, but then it's going to go slightly downwards again. And there's different ways to show this data visually. So that's one way, by using the plot right there by date and price. And then another one right here is they're going to show you. So you can say plot components with the forecast. And again, it's kind of the same concept, whereas you can see what this basically is saying. Here's the historical data, and based on the future predicted data, it's trending downwards. That's what the price is. So it's tending to trend downwards for the avocado. So that's just saying through these different periods, the prices of the avocados are going to dip. They tend to rise in August, but then they tend to dip downwards in the winter. So you're going to see it go up in the summer and dip a little bit low in the winter. And yearly, this is kind of interesting too. This is showing the yearly trend for prices and such. As you can see, they tend to be a little bit lower in February, March, but as the summer comes up, the prices tend to rise, and then they go back down in January again. I find that very interesting, and this is based on using the forecast, the yearly forecast predictions going forward 1 year. So this is kind of like for the next year that doesn't exist, just what it's predicting for you. Another thing is you can do right here. So we decided not only are we doing predictions by the date and the price, but we can also do it by region, because the data set again was broken out by the different regions that you would have. How do we know that? So what I'm going to do right here, I think you could say avocado df, and if you remember, we said value counts. I'm going to do this by region dot value counts. See again. So as you can see, these are all your different regions. So in this case, we're going to prep this a different set of forecasting for regions instead of by year. As a matter of fact, I had the value counts right here. So now what we're going to do here, here's another interesting thing. Let's just say we only want Northeast region. So in the lab itself, they had different regions, but I was just kind of playing around with different regions. And so I decided to pluck out just the Northeast region. This is kind of like a query. So I'm saying out of all of this data in our data frame, I only want the Northeast one. And I'm going to assign it to this df sample variable, and I'm going to sort by date. So if you look here, that's what you're getting down here. Notice the region here, it's all going to be Northeast. You're not going to find any other data outside of that, and that's just simply because of this. So what we want to do is we want to find the trend for the Northeast region, predicting going forward in the future, and by getting the average price. So there's different ways to plot it right here. This particular chart just kind of showing some interesting fluctuations as we go along. So here's our price, and then going forward in our x-axis. Unfortunately, this is hard to read down here. So what we can do is kind of give you a different view of it. So let's go and scroll down. That's kind of what I'm doing right here. But we're creating another profit object, and we're going to actually fit this df sample avocado, which is our Northeast region. We're going to train our model just with that data. And based on that, we're going to create another future object going forward 1 year. Pretty slick right here. And then we're predicting for the future. And I actually, let's see what we've got here. We've got our date and our price. Let's see here. That's by, actually this looks like this one's for date, not for, we've got our figure. Yes, profit. There we go. I just had a little bit of a brain lapse there. This is by the Northeast region, and by date we actually want to plot. So for Northeast, as you can see, based on our historical data, which gets cut off right here, up to like this point in period of time, this is what our actual data is. And so the profit object with its algorithms and stuff is kind of projecting this to be future. And as you can see in this case right here, by the Northeast region, we have a very slight upward trend going in the future. Because if you look here from 2015 on up with our real data, we had a slight upward trend. If you can kind of look and see where this cuts off, it's trending slightly upwards, which is why the future is predicting along the same way. And we're kind of seeing this right here, projected here. It's doing a slight upwards trend, which is what you're seeing right here with this little shading here. That's kind of like the future, as well as a slight downward trend. And that's for the periods right here. And then going forward, like in the future, this is a trend for the Northeast region only for January through January. So it tends to say that July tends to be the best month. And then as the summer wears on, it tends to go back down again. So the cool thing about this, that was the Northeast region. There's nothing to stop you from doing a totally different one, which is what, we can do. So let me see if there's anything else which I wanted to show you. No, there isn't. So what I could do technically is take a look at the data set, and we can do it for Albany for that matter, or we can do it for Las Vegas. Let's take a look at Las Vegas and see if that's a little bit different. So I'm just kind of winging this right here. So if I scroll down ever so slightly to where we had the Northeast region, where was that? See, it's a beauty. You can tell I'm not practicing this, or I didn't rehearse this. So you can see me in all of my mistakes and glory. So I am going to do Las Vegas right there. So, and now I want to do the sort by Las Vegas. So now what we've got right here, if you look at the region, so I've actually updated. So now we're going to do Las Vegas and see what happens. We do the average price there. We're going to see some different results here for Las Vegas. It looks slightly different. Let's go and take a look at that. We're going to rename our columns, and then we're going to dump this out so you can see Las Vegas. Now we're going to go through our model profit object again, run it all over again, and now what I want to do is I want to make another future object based on Las Vegas for 1 year. So it's executing, so it's creating this future object. Let's take a look and see, here's another thing, I'm just fishing. If I just dumped out the future, that's kind of nice. Kind of tells you the periods and how it would break it out. So we can actually delete a line by saying DD, DD. Now I actually want to plot the future, so I'm just rerunning it. So as you can tell, this looks a little bit different than our Northeast region. So this is for Las Vegas. So it does have a slight upward trend, but here's the future prediction again. Very different. So we actually want to rerun this. Now this is, I find interesting. This looks very different. As you can see, it's a constant upward trend of avocados. And I think I kind of want to attribute that to like the population growth and such in Las Vegas. You can have more sales. What this is telling you, which I also find kind of interesting, whereas with our Northeast data, we tended to peak in July. And if you look at the Las Vegas data, we're peaking like kind of in the October range. So probably because it's a little bit warmer in Las Vegas, you're going to see a trend or a shift there. So I kind of find this really fascinating. So what if we want to do 2 years? As you could say 720 right there. So now we're creating a future object 2 years in the future for Las Vegas. And now if we want to plot that and forecast it, as you can see, now we've got the year 2019 and 2020. So it's going to kind of show you more of what's going on there. Now we can actually forecast that. And as you can see, used to go up to 2019. Now it's going through 2020. So I think this is pretty much where I'm going to stop on this. But these are the kinds of things you'll learn if you take this deep learning course right here with a practical workout. So it's just helping to give me a little bit of a deeper dive into the course, but that's where they kind of go over the avocado case study. Very interesting. I hope this helps, and thank you for watching, and I'm sorry if I kind of rambled on or was saying a lot of ums, but again, I hope this helps. So you have yourself a good one, and hope to see you or talk to you or what have you in the future. Bye-bye.